Okay, section 6, we're going to kind of pull everything together as far as we're going to talk about, the different ways that we have tried to solve quadratic equations up to this point. As far as we've graphed, we've factored, we've completed the square, and now we're going to look at the last way that we can do that, which is using the quadratic formula. Now, you should have used the quadratic formula in Algebra 1. If you don't remember, you're going to have plenty of opportunities here to take a look at that and kind of refresh your memory a little bit. Now, the thing about the quadratic formula is it's a way in which you can solve any type of quadratic equation. The thing about it that sometimes turns people off a little bit is the simple fact that it does tend to get to be a little bit longer, but it is simpler in the fact that you're just kind of filling things in. All right, so what we're going to look at is there's really only kind of one new term that we have to worry about, and that's the discriminant. And what the discriminant is the portion of the quadratic formula that is beneath the square root. All right, so we'll get to that a little bit more here in a second. All right, but first I kind of have to talk about where we are and how we're going to use the quadratic formula. All right, all this is really doing here is kind of summing up everything that we've done in Chapter 5 to this point. All right, graphing, we've made some tables. We haven't done that a whole lot, but we focused a lot on factoring, using the square root property, and even completing the square. All right, now I'm still sold on the fact that if you can factor something, factoring is always your best bet. All right, it makes things easiest. However, it really only works when your roots or your solutions are whole numbers or integers or even a couple fractions in there. All right, there are going to be cases where factoring does not work. So you're going to have your options. Now, like I said, we talked about when to just use square roots, basically in the absence of that b term, okay, or that middle term. We've also talked a little bit about completing the square. Now, as I mentioned in class, we talk about completing the square. It's one of those things where you're going to be required to do a couple problems where you complete the square, but it's not one of those strategies that you have to absolutely use if you don't want to. All right, so again, jumping to the quadratic formula here a little bit, what we're doing is we can solve any type of quadratic equation using the quadratic formula. So if you're not really great at factoring, you don't remember when to use square roots, and you're not very great at completing the square, you can fall back on the quadratic formula. Now, all this is up here right now is just explaining basically where the quadratic formula comes from. Now, what it is on the right here. On the left, it's kind of showing the whole completing the square idea, but on the right, over here, what we're doing is we're taking standard form, and essentially we're applying everything we would do if we're going to complete the square. All right, and what it does is it works us all the way down to the bottom where we arrive at the quadratic formula. So that part that I boxed in the bottom corner is what the quadratic formula looks like. It's just another way to solve for x, okay, or solve for your x values that represent where your parabola would cross the x-axis. Now you can see it looks a little bit more complicated. It's not really as bad as it looks because the letters, the a's, the b's, and the c's are simply just the coefficients from the standard form of the equation. All right, so what we want to do is kind of take things out of that standard form and fill them into the quadratic formula. Now, what this is saying here is when you get to the end of your kind of quadratic formula thing, when you start simplifying and you have fractions, you just need to remember that when you're adding and subtracting fractions, you have to have common denominators. Now, again, if this doesn't make a whole lot of sense to you, that's okay. Really, we don't worry a whole ton about the whole fraction thing with the quadratic formula because eventually things just kind of take care of themselves. All right. Again, this is just something else that's kind of explaining the whole idea of where the quadratic formula fits in with everything we've talked about. Okay, so this part up here, like I said, essentially we're looking at what the quadratic formula looks like. The reason it looks a little bit different when we actually see the quadratic formula is because these two are the same, right? Or you have the same denominators. Essentially, you're adding fractions. We pretty much just arrive at writing one thing all over 2a. All right. So, without any further ado, so to speak, we're going to take a look at what we're going to use as far as the quadratic formula is concerned. All right. So this part in the middle is what we're going to fill into. Okay. So we're solving for x. So we're just going to start filling values in for everything that's in that quadratic formula. All right, now as you can see, the whole thing is written over 2a, which essentially means, because of that plus or minus there, that you could split that up and write it as two separate parts, kind of like I talked about on the previous slide. Negative b over 2a plus the square root of b squared minus 4ac all over 2a. But this simplifies things a lot more, where we only have one denominator, so there's less we have to fill into. And like I said before, we don't have to worry so much about combining fractions. All right, so what we're going to do is we're going to take that, and you should make sure you have it written down somewhere. And I know in your notes there's lots of spaces and lots of things that are asking about the quadratic formula, so make sure you get it written down. You're going to need to have it memorized. All right, it's not something you're going to be able to refer back to your notes, so you're going to need to make sure you know what it is, what it looks like, and how to use it. All right, so what we're going to do is we're going to take that, and we're basically just going to start finding zeros, finding roots, solving quadratic equations using the quadratic formula. Now again, I still want you to think about the whole idea that eventually any option, or any strategy I should say, is going to be an option when you solve these. All right, I still think when you have something that's written in standard form like you have here, or when you get something written in standard form, you should try to see if you can factor it. All right, if you can't factor it and you don't want to use some of those other methods like completing the square, you can jump straight to the quadratic formula. All right, now I'm just going to use the quadratic formula in this case to show us how it works. All right, but I want you to remember that you should keep all your options open. All right, so negative b plus or minus the square root b squared minus 4ac, and that is all over 2a. Now I wrote it there because we're going to fill into it, but we should kind of have a general idea what this is going to look like. So negative b would be the opposite of whatever b is. So in this case it's negative 16, so I'm going to put 16. Plus or minus the square root b squared. So if we take negative 16 and we square it, all right, and sometimes you're going to get some relatively large numbers here. Like in this case, if we take negative 16 and square it, we get 256 minus. Now usually what I do is I write out this entire second part, so 4 times a times c, just to make sure that we get everything written there and we don't worry too much about signs and all that stuff. And on the bottom we'd have 2 times a. So again, all those numbers that I filled in just come from the numbers that are up here in colors. Okay, the a's, the b's, and the c's. You have to make sure you keep in mind that the signs in front of both the b's, well, the a's, b's, and the c's have to be factored into your equation when you're thinking about it. Okay, and if you get the wrong sign and you fill in the wrong number, automatically you can pretty much kiss getting a correct solution goodbye, because it's going to be out the window. All right, now if we kind of simplify things a little bit, 256. Now I always leave the minus sign, and I do whatever math I have to do with the numbers, and then I come back and change signs if I want to. So in this case, I'm just going to take positive 4 times 2 times positive 27, which gives me 216. All right, now because I left the minus there, I can see that it's going to be minus, and that's typically where I see the biggest number of mistakes with these types of problems. Is a lot of people get the incorrect number inside of the square root. All right, so if we keep this going, I'm going to have to subtract that 256 and 216. All right, so moving down here, I still have 16 plus or minus square root of, basically I just said 256 minus 216 is going to be 40, and that's all still over 4. All right, now the next thing I want to look at here is I have to look at that square root. Can I break that square root down? Well, 40 is not a perfect square, but there is a perfect square that goes into 40, which is 4. So I'm going to think about the square root of 40 as the square root of 4 times the square root of 10. All right, so what that allows me to do is I now have 16 plus or minus. If I take the square root of 4, I get 2 square root of 10 over 4. Now, a lot of people tend to think I'm done at this point. I have to keep things in perspective and understand that I still have basically a fraction here. So what I'm looking for is all three numbers, the 16, the 2, and the 4. Do they all have something in common that I can divide them all by? And in this case, they are all divisible by 2. So what I'm going to do is I'm going to divide them all by 2, and I will get this. Okay? Now, remember, you can't divide a number that is not under a square root into a number that is in a square root. So that's why we didn't do anything with the square root of 10. We just left it alone. All right? Now, something else to keep in mind here is a lot of places, a lot of books will write things like this, the way that I have this answer down here in the corner. The other thing to keep in mind is because technically you have two terms on the top. If you wanted to divide them each individually by 2, because they're all over 2, you could, and you could actually get an answer of 4 plus or minus the square root of 10 over 2. Okay, so basically in those cases I'm just dividing both of those by 2. Now the reason I bring that up is because some books, like I said, will write it the way I have it squared or boxed up here in the corner. Other books will only write it like this. So I want you to make sure that you understand the difference or the relationship between those two, because if you have a book that writes it like the way that I circled it up here at top, but you leave your answer like this on the bottom, you need to be able to understand that both of them are correct. All right? The one on the top that's circled just kind of takes things a step further than we really need to take them. All right? So what I would like you to do is kind of take all that stuff that I talked about on the previous slide, and I want you to apply it to this problem. Now I'm going to write the quadratic formula up here for you so you can already see what it looks like and how you're going to fill into it. All right, so pause your video, work through that problem, come back, and we'll talk about the solution. All right, now all I'm going to do, like I said before, is I'm basically just filling in numbers. So negative b, or the opposite of b would be negative 3 in this case, plus or minus the square root of b squared is going to be 9, minus, I'm going to go 4 times a times c. I'm going to put that all over 2 times a. All right, now again, here in the middle, what I'm going to do under the square root is I'm just going to say I have 9. All right, I'm going to leave the minus for right now. So I'm going to say 4 times 1 times negative 7 is actually negative 28. All right, and that's all going to be over 2. All right, now because I have a negative and a negative together, I'm going to change those to a positive. So if I come down here and write what I now have, 3 plus or minus, it's going to be the square root of, what, 37 over 2. All right, because 9 plus 28 is 37. All right, now this one becomes a lot easier than the last one because if I look at what I have, I can't do anything with the square root of 37 because 37 is prime. So obviously no perfect squares go into it. And if I look at my negative 3, the 1 that is technically out front here, and the 2 on the bottom, those don't have anything in common that I could divide out of all three. So because I can't do anything else with it, what I have up there is essentially my answer. Now again, some books will take it a little bit further, and they'll say you actually have negative 3 over 2 plus or minus the square root of 37 over 2. All right, either answer is correct. All right, you just have to understand that going from here to here, they're just taking this 2 and dividing it into both of the terms that are on the top. All right, because essentially that's what happens if you have something that's all over the same number. All right, now the next thing we're going to talk about, and this should start to kind of move a little bit quicker for us, same idea. Okay, I'm going to use the quadratic formula, but you're not always going to get zeros or roots that are real numbers. Okay, so what I'm looking at right here is I'm going to fill in to my quadratic formula. So negative b plus or minus the square root of b squared, which in this case would be 9, minus 4 times 4 times 2. All right, and that's all going to be over 2 times 4. So again, just filling things in based on what my a is, my b is, and my c is. Okay, now simplify things a little bit step by step. And some of you are going to get to the point where you start to do this a little bit quicker. I'm just going to continue to write everything out so you can see everything step by step. But in this case, 9, I'm going to leave that minus sign and I'm going to multiply everything else. Okay, so 4 times 4 is 16, times 2 is 32. All right, and that's all going to be over 8. Now you can already see inside the square root here what's going to end up happening. I'm going to end up getting a negative number. All right, so 9 minus 32 is going to be negative 23, and I have my 8 on the bottom. Okay, now if we look at what's going on, if we have the negative, remember from the last lesson, what we have to do is we have to write an I out front of my square root. And remember, the I represents the square root of negative 1. All right, now at this point, I would look at that square root of 23 and see if there's anything I can do to simplify it. 23 again is prime. There's no perfect squares that are going to go into it, so I can't do anything else. Now I just want to look at this number, technically the number that's there, and this number. Are they all divisible by something in common other than 1? Or in this case, no, they are not. All right, so I can leave my answer like this, or sometimes again you'll see it like this. All right, same idea. All right, they're just taking it, or I'm just taking it, I guess I should say, a step further and writing them as two separate fractions. All right, and again, as we go through this, just remember this still represents two answers. Okay, in the case that they're real numbers where we don't have any i's, you're still representing the points at which the parabola would cross the x-axis. Remember, once we get into something like this where we have complex zeros, okay, that involve imaginary numbers, we don't have any place where we're crossing the x-axis. Okay, so you're going to kind of have a parabola that's kind of floating out in the middle of nowhere, not intersecting the x-axis at all. All right, so again, take a look at this one, work through it, see what it is that you can come up with for an answer. All right, same idea. We're just going to kind of work forward here. So x equals negative b. Now in this case, negative b is going to be 1 plus or minus square root of b squared. Well, it's just going to be 1 squared minus 4 times a times c, all over 2 times 3. Okay, remember, if there's an x but there's nothing really in front of it, we have to assume that there's a 1 there. All right, the other thing I want to bring up is at some points, you know, you're going to have complete terms that are missing. You know, you might have something like this. All right, all that means is you don't have anything there with an x, so it means you don't have a b at all. So what you would do is you just fill 0 in, okay, wherever there's supposed to be a b. All right, and the same can apply for the c term. Sometimes you won't have, like in this case, there's a plus 8 back here. Sometimes there won't be anything back there. So that just means you fill a 0 in for c. All right, so if you're missing terms, just put a 0 in place of whatever letter is supposed to be represented by. Okay, so let's come down here and simplify. 1 plus or minus square root of 1 minus, I'm going to have 4 times 3, which is 12, times 8, which is going to give me 96. All right, and on the bottom I'm going to have 6. Now again, you should be able to see that we're going to get a negative number under my radical here. All right, so we're going to have something that looks like this. Your first step before you even worry about dealing with that 95 is I have to make sure that I take and I write an I out front. Okay, remember, it represents the square root of negative 1. All right, so I get that out of there so I can take care of it. Now, This one might require a little bit of work. We have to think a little bit here. You know, is 95, can it be divided by a perfect square? And I'm kind of trying these here. 95 divided by 36 isn't going to work. 95, and you get any bigger than that, we got 64. 95 divided by 4. Oops. Not going to work either. So, as far as I can tell, 95 is prime. Alright, so, well, I shouldn't say it's prime, because 5 would go into it, but there's not a perfect square that's going to go into it. Alright, and because we can't find a perfect square to go into it, we just have to leave it as is. Alright, now, the last kind of part of this assignment here, and we'll have a story problem at the end too to look at, but the last thing we're going to talk about is the discriminant, which I brought up at the beginning of the lesson. Now, the discriminant is just the expression of the quadratic formula that is under the square root. Alright? Now, what we do is we use the discriminant to determine how many solutions and what type of solutions a quadratic equation can have. So what we're looking at basically is, if we fill into the discriminant and we get a positive number, that means I'm going to have 2 real number solutions. Alright? If I fill into the discriminant and I actually get a 0 under there, that means I'm only going to have 1 real number solution. So remember, you know, if you end up with something that looks like this, alright, you can take the square root of 0, which is just 0. So essentially what you would just have here is 2/3. Alright, so you would only end up with 1 answer if there's a 0 under the square root in the quadratic formula. Alright, and then, like we just showed, if you get a negative number underneath the square root, you end up with 2 complex solutions, okay, or 2 solutions that involve imaginary numbers. So, what you're going to be asked here in some of these cases, and you do have a chart like this on your notes, so you need to make sure you fill it out, okay? But basically what you're looking at is my discriminant greater than 0? Is it 0 itself? Or is it less than 0, or a negative number? Alright? That is going to dictate how many and what type of solutions you're going to have. So, when you are asked to figure out basically how many or what type of solutions a quadratic equation has, you're going to fill in the discriminant. If it's greater than 0, you're going to write 2 distinct real solutions. If you get 0, you are going to write 1 distinct real solution. And if you get a negative number, you are going to say 2 distinct non-real complex solutions. Or if you want to just say 2 real solutions, 1 real solution, and 2 complex solutions, you can do that too. It all pretty much means the same thing. Alright? Now remember, the other thing down here is, remember when you're filling into the discriminant, you're not including the square root with it. You're just trying to figure out a number. Okay, just b squared minus 4ac. Alright, so when we do this, the first thing I should always do, just like we talked about before, you need to make sure that you are in standard form. Alright, the quadratic formula, just like factoring, only works if you're in standard form. Now, b squared is going to be 144 minus 4 times a times c. Alright, so essentially 144 minus whatever 4 times 36 is, which is 144. Alright, so 144 minus 144 is 0. Alright, because I got 0, that means I am going to have 1 real number solution. That is all these questions are asking for. You don't have to solve anything. You just have to say how many solutions and what type are they going to be. So in this case, 1 real number solution. Alright, here's another example of what we got going on here. Again, we want to make sure that we write it in standard form. So I'm going to subtract that 12x over, set it equal to 0. So again, b squared, 144, minus 4 times 1 times 40. Okay, well, 4 times 40 is going to give me 160. So 144 minus 160 is going to equal negative 16. Alright, we got a negative number. What that means is I'm going to have 2 solutions, alright, and they're going to be complex. Or they're going to include an I. Okay, again, that's all you really have to write. All right, now for time's sake, because you should get the general idea here, I'm not going to go through the next example. In this case, had this negative 16 been a positive 16, then the only thing you would have changed about your answer is you would be getting 2 real number solutions. All right, so use your notes, use that stuff from what we're talking about, all the stuff, information from the video. Make sure you understand what the question is asking and what you're supposed to find. All right, now this graph right here just shows the difference between what would happen if you're going to have 2 real number solutions, which would be like this one in blue down here. If you're just going to have 1 real number solution, meaning we're only going to intersect the x-axis in one spot, or if you're going to have 2 complex solutions, which is kind of what we talked about before, like with that green parabola up there, it's just kind of floating or hanging out in the middle of nowhere. It doesn't cross the x-axis. All right? So the last thing that we need to talk about here a little bit is you're going to have a story problem or 2 that you have to deal with. All right, now use some common sense when you're going through these. We just talked about using the quadratic formula for the majority of this assignment. So you're probably going to use the quadratic formula to solve the story problems that are going on here. All right, now this kind of puts 2 different ideas together. It says an athlete on a track team throws a shot put. The height of the shot put, measured in y, in feet per second, after it is thrown, is modeled by y equals negative 16t squared plus 24.6t plus 6.5. The horizontal x distance in between the athlete and the shot put is modeled by x equals 29.3t. To the nearest foot, how far does the shot put land from the athlete? So what we're looking at here is we're trying to figure out how far away it lands. Eventually we're going to have to fill something into this equation. All right, so what we want to do is we want to figure out, based on this equation up here, what t is going to be. Okay, that equation right there is supposed to model our up and down height, our vertical height. So what we're looking for is at the end, if we're talking about throwing a shot put, all right, at the end and at the beginning, your height would be 0. So if we use the quadratic formula to figure out what t is when this is set equal to 0, all right, so essentially we're going to be putting a 0 in where this y is, all right, which would make it in standard form. We're going to use the quadratic formula to figure out what 2 answers essentially are going to give me 0. One would represent the beginning, one would represent the end. All right, so I'm going to go, we have t's instead of x's, so I'm just going to go like this. Same idea. So negative b 24.6 plus or minus the square root of b squared. So 24.6 squared is going to be 605.16. I have to extend my square root a little bit here. All right, minus 4 times negative 16 times c. All right, and that is going to all be over 2 times a. All right, now the whole idea here is, okay, again, we should be getting essentially 2 different answers. Okay, it starts off with decimals, so this is one of those few occasions where as we go through, you're probably going to represent everything in terms of decimals if you can. All right, so let's kind of get straightened out what we got going on inside here. So we'll leave the negative. So 4 times negative 16 is negative 64. Take that times 6.5. So I'm going to end up getting negative 416 in here. But I actually have 605.16 minus that. So we're going to add those 2 together. So 605.16 plus 416 is going to give me 1021.16 inside my square root. I still have negative 24.6 plus or minus that all over negative 32. Okay, so now what we're looking at here is we're actually going to get decimal numbers as answers. So I'm going to go ahead and take the square root of the number that is underneath the square root. So if I take the square root of this, I actually get 31.96. All right, I have negative 24.6, and on the bottom, negative 32. Okay, so what I'm going to do in this case is I want to go ahead and I want to figure out what my two answers would be if I were to write them in terms of decimals. All right, so negative 24.6 plus 31.96 divided by negative 32, I get a negative number, okay, like negative 0.23. All right, now I'll explain why it's negative here in a second. All right, so then I'm going to go the other way, negative 24.6 minus 31.96 divided by negative 32, I get 1.7675. All right, now obviously if this is supposed to represent time, I have to use the positive number. Now the reason that the other one is negative, which is supposed to represent where we start, the reason it's a negative time is because we're not throwing it from the ground. We're actually throwing it starting from up here a little bit. So the equation takes into account the entire parabola. So it's taking into account that we're actually starting from down here. All right, but when in reality we're starting up here. So this is kind of my t equals 0 point, but you can see that technically I've moved up a little bit, so that's going to represent like whatever the height of the thrower would be. All right, so this number down here represents how long it would take for us to get to here. All right, or basically to end the throw. So what I now want to do with this number that I found down here is I want to fill it into this equation. So essentially I'm going to take 29.3 and I'm going to multiply it by 1.7675. All right, and I'm going to get 51.79. All right, now this would represent the horizontal distance in feet, all right, that we threw the actual shot put. All right, now the first thing I get with a lot of these questions here is, oh my gosh, there's all these decimals and stuff. Just make sure you keep track of what's going on. This is one of the few occasions where when we're solving quadratic equations, we actually are allowed to use decimals. All right, story problems, a lot of times if they present things in decimal form, we're going to go ahead and we're going to take things out to decimals at the end. All right, so you're going to have a couple of those. Again, use the quadratic formula to figure out what your values are that give you 0. And whatever that value is that comes out, all right, the one that actually makes sense, like we had down here, the positive time, you fill that into the other equation and figure out what the problem is trying to ask of you. All right, now, last couple things I got here, you have a lot of charts and stuff on the ending part of your notes. All right, what it's doing is it wants you to compare basically all the methods that we've talked about as far as trying to solve quadratic equations are concerned. All right, this right here outlines graphing, factoring, square roots. When should I use it? When should I not use it? Examples of what happens when you actually do go ahead and use it. All right, here talks about the two most recent strategies that we've used, completing the square and using the quadratic formula. So now the whole idea here is this should pull everything together and kind of give you a better idea of when you should use a particular strategy. And again, I'm going to continue to say this. I still think factoring is your best bet if you can get things to factor. All right. If not, when you're comfortable with completing the square, go for it. If not, you can always fall back on the quadratic formula like we just talked about here. Just make sure when you're using the quadratic formulas, all right, in this area in here, you need to make sure that you get the correct signs on things. If you do not, it's going to throw off the entire problem. Okay? Now, the last thing is, regardless of which strategy that you use to do this, all of them should give you the same answer. Okay? So even if you could have factored something, but you use the quadratic formula instead, you still should get the same answer. All right? So something to keep in mind as we move forward here a little bit. All right, now that is all that I have for you as far as this particular lesson is concerned. Please make sure you get a good start on your homework and make sure you ask some questions if you don't know what's going on. But for the most part, the video itself was very informative. Anything that you need to know to work on your homework is in the video. All right, so you need to make sure that you are watching these videos to learn and actually try to get something out of it, not to just write stuff down and try to get done with it as soon as you possibly can.